Yes. Today, I just want to. We're going to be talking about radical functions. I believe it's the last family of functions we really have to talk about. I have to go back and look at my notes and see what we covered before we got kicked out of school. But I believe this is the last one we really have to cover, and it's a little bit different in the fact that you can't just kind of put whatever number you want into it. Okay. So first of all, let's talk about what a radical is. Okay, and what a square root is, and everything like that. Okay. Now we should know what a square root is, right? So if I said what's the square root of 9, you would tell me that it is positive or negative 3. If I said, what is the square root of 25, you would tell me it is positive or negative 5. If I said, what is the square root of 0, you would say 0, right? Because 3 times 3 makes 9, or negative 3 times negative 3 makes 9. 5 times 5 makes 25, negative 5 times negative 5 makes 25, and 0 times 0 makes 0, right? Now, because it is a function, we are only allowed to have one answer. So right off the bat, the first thing we want to say is no more negative numbers. Okay, so right now it's square root of 9, back to old school square roots, what we call the principal square roots, okay? And so like I said, you know, if I said what's the square root of 64, now it's just 8, okay? But if you guys remember when we talked about radicals initially, we talked about simplifying radicals and all these things. There were some kind of problems, right? One of them is that a majority of numbers, an overwhelming majority of numbers, gave you irrational answers, right? So if I said, hey, what's the square root of 2? You'd be like, oh, it's 1.414, I forgot what it is, 35, something like that. Okay, it's an irrational number, right? It's a number like, you know, like pi is a common one we know. But most numbers, give us this, right? And we need to be careful saying most because there's actually infinity of both. That's okay. 412.135. All right, so I forgot the 2135. Okay. Again, this is what we call an irrational number. And most numbers, again, if we think about it, if I say, hey, what's the square root of 3? Square root of 3 is that, right? Square root of 4, well, that'll be nice, right? But then, let's think, oops. Square root of 4. Right? But then, again, I go square root of 5, and again, another irrational number. Square root of 6, irrational number. Square root of 7, irrational number. Square root of 8, irrational number. Square root of 9, perfect square. 10, irrational. 11, so we get more irrational answers than we get, you know, good numbers, good integer answers that we can do. And the thing is, with functions, what eventually we're going to want to do is we are going to want to graph them. And you can't graph an irrational number. You can estimate it, but you can't graph those irrational numbers. So what's really important is that you're picking numbers that will give you good answers, right? That will give you things. So if I said, hey, let's start with the parent function, f of x is equal to the square root of x. Well, now let's think about what we want to plug in. First of all, negative numbers are out, right? Negative square roots don't work, right? Actually, if you guys want to know about negative square roots, I'm doing that with my 11, 12 class right now. But typically, if I put in what's the square root of a number, it tells you it's a non-real answer. So no negative numbers, there's a limitation there. So there are numbers we cannot put in. No negative numbers go in. So what's the smallest number we can put in? 0. And the square root of 0 is 0. So there's a point right there. Can I put in 1? Sure. Square root of 1 is 1. So 1, 1. Right, 1, 1. Can I put in 2? No. Can I put in 3? No. Can I put in 4? Yes. Because the square root of 4 is 2. So 1, 2, 3, 4, 1, 2. Can I plug in 5? No. 6? No. 7? No. 8? No. 9. So the square root of 9 is 3, right? And there you go. Now we start to have this. The next number you'll be able to put in is 16 and then 25. And this is going to be our parent function here. If you notice, remember the, what if I said x and the f of x was equal to x squared? If you notice this, 0, 1, 2, 3, if you notice, this is an inverse function, 1, 2, 4, 9. that these numbers are flipped. Yes? So if you kind of think about this, this is half a parabola turned sideways. Okay? But again, we can only take the positive numbers because it's got to pass the vertical line test. Now, we'll talk about the transformations and how they're going to be the same types of translations and moving this around and everything like that. What I want to talk about today is how you're going to figure out how to evaluate these functions. So if I said g of x is equal to square root of x plus 9, okay? Let's talk about what would be a good number to put in there. Well, let's think about this. Do I want to plug in 0? Sure, right? Because I can say 0 plus 9 is 9, which is 3. Right, so 0 is okay. Do I want to plug in 1 to this? No, because if I plug in 1, I get 1 plus 9, which is the square root of 10, which is an irrational number. It's something I cannot graph, okay? So what you're going to have to be real careful with these functions is, hey, what numbers am I going to put into these, okay? So we have to be a little bit careful, and knowing this kind of pattern here is going to be very beneficial to us. That I went up by 1, that I went up by 3, that I went up by 5. So we'll talk about that in the days to come. Today I really just want to give you guys an overview. All you really have to do on IXL today, guys, is they're going to ask you to plug some numbers in. Now this is one of the more complicated ones. All they're going to do is ask you to evaluate these functions. In other words, if I plug in 54, right, what am I going to get out? Well, again, if you want to, first of all, you can use a calculator. I will not hold it against you if you guys use a calculator. If I said, all right, well, -2 times the square root of 54 plus 67. Okay? Again, you should get something like that, okay? If you want to do it by hand, 54 plus 67. Uh, 54 plus 67 is going to be 121. So because what we got in here was a perfect square, this becomes an answer that we would be able to graph, an answer that would make sense, okay? So what I really want you guys to focus on today is when you're doing some of these problems is, hey, when I plugged in this number, did I get out a perfect square? And so I just want you guys to think about that. You need to get a perfect square to come out, so you kind of have to have a knowledge of what your perfect squares are, okay? Now we'll talk about how you're going to get around this, and the different ways you can graph it, and different ways we can kind of take some shortcuts. But for today, all I need you guys to focus on is that they are choosing these numbers for a reason. They're choosing these numbers because they're giving you a perfect square, okay? So give those a try today, real easy today. I do all want to show you, I know we've been jumping around a little bit just because it's tough doing, you know, math and things like that online. It really is kind of a huge pain, but we are going to be working right here. So I am going to do my best to just kind of go straight down through this. I know we've been kind of jumping. We did a couple from here, and we did every other one here. It's just we had done absolute value functions, so we're fine with that. It is a little bit tricky doing this, so I'm going to do my best to go straight through these next 5. So if you want to get a head start on things, you can go ahead and do all those things. So while I'm here, I want that to be given to 9th grade. Okay? All right, guys, I will talk to you tomorrow. Take it easy.